Hello everyone, welcome back to my channel Chemistry with Rahul. So I hope you all are doing great. So now today we will be moving to the next part of this chapter, which is related to like that is nothing but uh, till now we have seen the electrolytic cell, and in electrolytic cell we have seen like Faraday's first law, second law, certain formulas that which are going to be very much important for the calculation part. And now we will be proceeding to the galvanic cells part, which is also called as a Lagrange cell, and also it is called as a voltaic cell. So now we will be moving towards, like in the first lecture itself, we have seen that like now we will be moving to the galvanic cell. Now we are going to move toward the galvanic cell. So before moving to this particular thing, galvanic cell, like here, it will be like a Daniel cell we are going to study about, because the Daniel cell itself, it is going to give us a brief idea about the given chapter over here. Okay. So before moving to this one, again, I'm going to repeat you the basic scenario or basic thing that we are going to require in this chapter. Always remember, because whenever we select the electrodes, that is a cathode or anode, we always do it by in whenever we are going, like generally students have a like one, like they use one term, that is anode should be a positive and cathode should be a negative part. So never do that thing. Always go with the, like whenever we start with the cathode, okay, whenever we have to select the cathode, so cathode must be the part where reduction should be happen. Okay, cathode is something where reduction should be takes place, and anode is a part where exactly the oxidation takes place, where exactly the oxidation takes place. So this is the thing that we are again going to require, because in galvanic and in electrolytic cell there are certain differences there, because many of times student get jumbled into this particular thing. So what we are going to use, we are going to use this trick over here, which is going to a beneficial part for us. So before moving to a galvanic cell, like we have already seen that, like in electrolytic cell, we have seen that electrical energy is converted to chemical energy. So in galvanic cell, basically we do a process, that is a chemical reaction is there. Basically, it is a chemical reaction. In this particular thing, chemical reaction is converted to electrical energy. Electrical energy in this scenario, this is very much like it is a application oriented. The late storage batteries are there, like rechargeable batteries are also there, or a Daniel cell, or what we can say that the cells which we use in our wristwatch or wall watches are there. These are the cells that these are the example of a galvanic cell. So this is very much important part. So that is, in this particular thing, there is a chemical reactions input, means chemical reaction will take place as an input, and at output we are going to get a electrical energy or energy simplified. So main purpose of this galvanic cell is to get the electrical energy. And this reaction, basically the second thing which we can say about this is a spontaneous redox reaction. This is what spontaneous redox reaction. Spontaneous redox reaction is there. Spontaneous means automatically it is going to happen, means we do not require external input for that particular thing. External input is not there, so we have to do this reaction. So reaction is going to take place by own. Okay, by own. So that means the reaction is going to put its energy into this particular thing. So due to this, the delta G value, that is Gibbs free energy change. Gibbs free energy change for this particular thing will be a negative, because the system is going to use its energy. That's why it will be a negative. That's why it will be a negative point. So This is a thing that we have to remember about the galvanic cell. In upcoming, like in few minutes, we'll be differentiating between electrolytic cell and galvanic cell also. So it is going to clear up, like in previous lectures also, it will be cleared. So suppose like many years ago, or we can say centuries ago, there was a one scientist. He was like, we know that the scientists, they are very much enthusiastic and like they are very much curious about the things. So they plant a laboratory in their backyards. So there was a one scientist who exactly did that. My name is, there was a one scientist who exactly did that particular thing in his backyard. So what exactly he did? He just took a beaker, like a normal beaker, we can say that, or we can take a flask. He took a one flask, and in that particular flask, he took a copper sulfate solution. He took a copper sulfate solution. Copper sulfate is always looks a blue in color. Okay, it imparts a blue color. Copper sulfate is a blue in color. So he used copper sulfate in particular flask, and he had one zinc rod with it. So what he did, he just placed that zinc rod inside that particular solution like this, and he kept that particular thing for like an hours. So he was standing there, he kept that particular reaction like that, and he went for his lunch, dinner, breakfast, whatever we can say that. So after certain hours when he came back, so earlier the solution was blue in color, zinc plate was there. We can say that this was a zinc rod. Okay, this was a zinc rod which he placed inside the solution. So after certain hours or certain like time interval, what he has the observation, he just came back and he saw that that particular solution, that particular solution is now turning to reddish like this one, and the zinc rod itself, now the zinc rod which he has dipped, it it's it was looking like that particular thing. Okay, so and there was certain formalities like here the residues was there like this, certain residues was there. So he was astonished by this thing, and like he was enthusiastic alongside. So he saw that like after certain time, this was our zinc rod, and this was a copper sulfate solution, CuSO4 solution, which was aqueous, which was aqueous. So earlier it was a blue. So what he has observed, this observation is very much important for our next study. What exactly, like in the field of galvanic cell, this was a, like a remarkable thing that that particular scientist has done. So the first observation, he saw that the first observation, this is very much important thing. That is the earlier, suppose the zinc was a flat and the square type, we can see that this is a square type. Now here it is making a slice of a pizza. Now from this we can easily understand that now it is reduced over here. Reduced means the weight has been lost over here. In simplified language we can say this. So here we can say that the weight the weight the weight of zinc rod, the weight of zinc rod decreased over here. Yes, we can see this from earlier. It was a flat. We can say flat like a square type of a rod was there, and after a certain time, it was become a slice of a pizza. So ultimately, this was the weight of that particular rod was decreased over there, and after certain time, again this there was a blue color solution. So this blue color solution was disappeared. It was disappeared. This was disappeared because there was certain like from the zinc certain things are going into that copper solution, and due to that particular thing, the solution has been changing its color. So this was the second observation. Simplified, we can see it by our naked eyes also. If you have a copper sulfate and zinc rod, you can do this in your backyard also. You can be like that particular scientist also. So in this case, this was the second thing, and after that there must be a no, one more, like a here, this particular thing, reddish brown, this reddish brown PPT, like this residue was there. There is an observation that is a reddish brown color was observed. And yes, now he tried to put that his hand into that particular solution. He just dipped into the solution, and earlier also he was like, whenever we mix the NaCl in the water, we can also feel that particular thing. This was not a, it is not going to harm this reaction. You are not going to get harmed by this reaction. So what he has done, he just took that particular solution and tries to put his hand into that particular solution. So he observed that the temperature was increased over there. Temperature was there. So this was the thing that we are going to require. Temperature increase means energy is going to release. Energy is released in this particular thing. So he was thinking like that. What exactly is going to happen? It happened into this particular thing. So he was thinking on that particular thing. So he came to a conclusion. What conclusion he has made? Like, there is a copper sulfate and zinc rod is there. So zinc rod is like it is the weight of zinc rod is decreasing over here. So he said he's like, with the help of electrochemical series also we can solve this particular thing, because the things which are on upper side and the things which are on the lower side, like upper side and the lower side, like from top to bottom, SRP is going to increase. SRP means standard reduction potential goes on increasing. So in that particular sequence, if zinc, we know that it is on the topper side and the copper it is on the lower side. So zinc is going to get oxidized over here, and the copper over here it is going to get reduced. That is simplified from the electrochemical series. We can solve this terminology over here. So what will happen? So here what he has saw, zinc over there, zinc has lost its 2 electron over here. Zinc loses 2 electron easily. We know that zinc, it is a pseudo d block element. Pseudo means it is not having that particular transition element property. So Zn plus 2 and loss of, here Zn, zinc is losing electrons. So loss of electron, we know that loss of electron is always referred as a oxidation. So when electron is into the particular reaction, we always term this reaction as a half oxidation reaction. So this reaction is happened with the zinc rod. That's why the weight of the zinc has been lost. Now after that, the copper will be there. So copper was inside the solution. The copper ion, the copper sulfate itself, it was in the solution. So copper ion, that it was also in +2 form. It will get this particular 2 electron and it will convert to the copper. Now here the electrochemical series, I'm again repeating you, electrochemical series is very much important. Go check my previous lectures. The mnemonics for, like, you will get n number of mnemonics on the online. So whichever you find easier, you just use it, because the upper side of the electrochemical series is going to get oxidized and the lower side that is going to get reduced. So what we are going to do, we are just going to add this reaction, half reduction reaction. We are going to just add it. Why we need to add this? Because we need to remove the electron, because in stable reaction we never show the electrons. So just remove these 2 electrons from left and right hand side, not from the same side. Always remember, both the electrons will be on the opposite side to each other. So this will be over here Zn, this will be plus Cu plus 2. Now this has been converted to Zn plus 2 and plus Cu. So from here we can see that zinc is converted to Zn plus 2, means it must be, if you want to take oxidation part, so Zn zinc should be on the anode side. Remember this now, because this is very much important. And if copper is getting converted to Cu plus 2, so here it is oxidation state is plus 2 and it is converted to 0, means reduction is taking place. And here it is 0 to plus 2, means oxidation is there. So this is the main frame that we need to keep in mind. This is how this is going to work. And along with this, as the temperature was there, we will get an energy part. We will get a energy. So this is very much important. This is the thing that we are going to require for this particular chapter. So this was the history behind the galvanic cell, how exactly the process started, that we have seen over here. The heat energy has been released. So what exactly after this, there are more scientists were there, those who were enthusiastic and some curious also. They were going to use this particular energy, that how we can utilize this energy for the application oriented process. So what they did, they took two different cells. Now we will see that. I hope till here it will be clear to you. So what they did, they just took two vessels like this. Okay, two vessels like this, simplified. They just took them, and what they did, they took, like here, zinc rod. They placed a zinc rod over here, and they placed a copper rod instead of zinc again over here. And they take like here in this one, they took a copper sulfate solution, means same rod, same solution. Just remember this. I will write it over here. Same electrode, same solution, for their respective flask, we can say. And here he took zinc sulfate. Now what he did, he took a zinc sulfate. So here we will be having a zinc sulfate aqueous solution. Okay, zinc sulfate solution. And in this case, we will be having a copper sulfate, CuSO4, and the electrode itself, it will be of copper electrode. This will be a copper, and this side we will be having a zinc. Okay, we will be having a zinc electrode. So now we are very much familiar what exactly we have to use as an electrode and what we have to use as a like cathode and anode. This is very much important. Like at cathode, always remember reduction will be there. There will be a one, we can say that, I will give you one mnemonic for this. Like if you all are familiar, like in Hindi we say that like there is a big jungle. So inside a jungle, like a mnemonic will be there. I'll be planting a mnemonic over here. So jungle is there. So there is a big jungle and we are going to use that particular thing. So in jungle, कि jungle में कौन आया? Jungle में, we can see that jungle में कौन आया? That we are going to use it over here. So jungle में कौन आया? So student will say, now if you want, you will say CR. CR means we know that it is a fox. Jungle में कौन आया? CR. And कैसे समझ में आया कि जंगल में कौन है? So CR, the owling is there. So CR की जो आवाज होती है, it is like आऊ, that we need to remember. So जंगल में कौन आया? That is a CR. And आवाज कैसी आई? आऊ की आवाज आई. So we need to remember this particular thing, that CR, that is very much important. That is these things are going to make your work easier. So C stands for cathode, we know that. C stands for cathode and R stands for, that is a reduction. So it is simplified. If I say jungle mein kaun aaya, that is CR. And how you get that, like CR is there, like you heard the voice, oh, just remember it like this. So this will be a anode. At anode, oxidation will be there. At anode, oxidation process will be there. So just remember this. This is very much important. जंगल में कौन आया? सियार. कैसे समझ में आया? Aau. Always remember this. This is very much important thing. This is going to be useful for. This is a mnemonic that is I made for like to understand this particular scenario. So now when we place certain whenever we place it like this, and we are just going to connect them. We are going to light a bulb over here. Okay, we are going to place a bulb over here, and we are just going to connect it. That's simplified. We have seen which one is anode, which one is cathode. That how we are going to decide. Like at anode, oxidation will be there. At anode, oxidation will be there. Now don't like do a mistake like positive is anode. So now student get confused over here. What is happening over here? So when the scientist has started this particular thing, like here from the zinc is over here. So zinc, we know that zinc rod itself, it is going to like the zinc, we know that this is Zn is going to form a Zn plus 2 and 2 electron over here. Yes, zinc has a tendency. So we have a zinc sulfate in the solution also, and zinc proper as a rod. So this zinc we are going to take. So this zinc is going to do this particular reaction over here. So we will be getting a Zn plus 2 in solution over here now. Okay, we will be getting a Zn plus 2 in the solution. And this electrons are over here, are placed on this particular electrode, and it will be flowing like this. So due to this zinc over here will acquire a negative charge. So this becomes a negative. So anode in case of galvanic cell is always negative. So remember it like this. Never do that mistake that anode is always a positive part. So always remember. And this will be a negative, and particular we have a zinc rod, and from that zinc rod continuously Zn plus 2 is delivered continuously, and so that this current is going to flow like this. Negative charge is going to flow, and here what will be going to happen? So the copper is there. We have a copper in this scenario over here. So Cu plus 2. Cu is always, we have seen that Cu is always in the, like, he is going to always take electron. In case of zinc is there, always remember the electrochemical series. He is going to take electron. He says, मैं ही लूंगा सारी चीजें. I am going to take electrons because I am placed in in electrochemical series. I am at the like on the downward side. That's why I'm going to take all the electrons. And zinc says, bye, I'm going to lose electrons. So copper over here, which is now here, their electrons are coming toward this side. So copper is over here, it is in a plus 2 form. It is going to take this particular. So it is going to making this particular as a positive side. So in case of galvanic cell, the reduction part is always a positive. Just simplified. This is the thing that we keep in mind. We have to keep in mind this particular thing, because students do this particular, like we call it zone in the proper understanding. So earlier this setup was there. There was a no, we are not providing external electricity over here. Always remember, because this is a spontaneous reaction, and spontaneous reaction means system is going to use its energy to properly, like it is going to convert that particular chemical to the electrical form. So whenever this circuit completes, this bulb, it started glowing. Jal gaya. So started glowing, and the scientist, it's himself, he was very much happy. He was like, oh, finally I did that. But the scenario was that initially this reaction was initially this reaction longed for a 2 to 3 minutes only. 2 to 3 minutes. So he was like bit of nervous, but he was very much happy because he has conducted his particular reaction over here, because this reaction was like he got the particular whatever, like he has aimed for that particular reaction to use that particular energy as a to glow the universe, whatever he was thinking of during that particular process. So initially this reaction was longed only for the 2 to 3 minutes. So after that, here we got that this will be a half reduction reaction on this side, and here it will be a half oxidation reaction, of course. So we are going to study more about this particular thing, what exactly is going to happen in this particular scenario. So now here student get confused. So what we are going to do, we will be distinguishing between galvanic cell and the electrolytic cell. So just try to put it over here. Like we have electrolytic cell. We are going to make 2 compartments over here, electrolytic cell, and yes, of course, our main part, that is a galvanic cell. Okay, so in terms of, let's write it over here. So in terms of electrolytic cell, we give external input. Yes, we remember that, like electrical input is there, and which is converted to chemical energy. It is hypothetical. Basically, we need to do certain reaction, and in case of this one, it is a non-spontaneous. It is not going. We have applied a certain amount of energy to this particular thing. Non-spontaneous. This is a non-spontaneous redox reaction. This will be a non-spontaneous redox reaction. And yes, of course, if it is a non-spontaneous, like suppose, how to understand this spontaneous and non-spontaneous reaction. Suppose if your mom is washing your clothes with hands, she's using her energy. Or if you are using your hand to wash your clothes or utensils, so you are using your energy over there. And if you have a electrical, like a washing machine, you are going to put that particular dirty cloth into washing machine. It is going to clean it by itself. So your energy was restored. Your energy has not been used. It was given by the external part. So when you do it by yourself, you are going to lose your energy. Losing means getting minus charge. And if you are using a washing machine, so you are having your positive charge will be like that only. So delta G, that is we call this as a Gibbs free energy. We call this as a Gibbs free energy is always positive in this case. That is delta G is always greater than 0 in this scenario. Delta G is greater over here. And in this case, we always take anode. We always take an anode as a positive, and we always take a cathode. We always take a cathode as a negative. So this is simplified. We understood this scenario. Now, in case of, we will be moving towards the another part. This is the first part. Here, this chemical reaction or chemical energy is converted into electrical energy that we have seen over here, how it has been converted over here. Yes. So in this part, like we are going to use our hands to wash our clothes. Remember it, this one like this. This will be a spontaneous redox reaction. This will be a spontaneous redox reaction. Spontaneous means we have to use our hands to wash our clothes. Remember it like this. So spontaneous redox reaction. So delta G will be always a negative. So due to this, delta G will be less than 0 also. And the fourth part, very much important, anode is always negative in this case. And cathode, whenever we will talk about the cathode will be always a positive part. So this is the thing that we need to remember. This is very much important part that students should be remember. Yes, because whenever we are dealing with this particular thing, we need to remember all these things because it is going to help us a lot to understand this chapter. So till date, remember this particular thing, like jungle mein kaun aaya? CR. And how you understand that particular thing? Because the CR makes a howling. Ow! Remember this. Okay. Till then, so keep on studying. If you have any doubt, please just ping me on YouTube also. and very soon we will be starting our own channel also. So stay tuned, keep on studying. Bye bye, have a nice day.